Hello, everybody, and welcome to the fifth webinar in the series. This is the fifth of, well, we originally planned 7, but there are going to be 6. We will see this in a moment. We will be looking at the BondLine and CustomLine product line systems today. As sparring partner for discussion to answer questions today, I have Andreas Ott, who is the head of our automation group. Andreas, could you quickly describe to the audience what your role is and why you are qualified to take part in this webinar?
Yeah, thank you, Greg. My name is Andreas Ott, and I'm happy to be here today. So I'm the head of automation group, working for ficonTEC now for 10 years. And my role is here to do the programming or to lead the group for programming the machines, the systems.
If I'm correct, I believe that effectively all the systems that go out to the customers run through your group at some point. Is that right?
That's right. That's absolutely right.
Good. Kevin, next slide, please. Thank you. So, as always, to make sure I don't forget the giveaway, there we have the usual giveaway of probably a mug and a pen and maybe something else that's probably standing on the desk in front of Andreas as we speak. The question for today is, and for this question, you will probably, I believe it's nowhere else, I believe you will have to look through the previous webinars, or maybe you have attended them all and can answer the question straight away. The question today is, what is our most popular or the most often delivered housing format as of the last couple of years? And the first person to add that to the chat will win the giveaway for today. Okay, good. Then moving on. So what is the news I have to announce this week? So some of you will obviously be aware to a greater or lesser extent that ficonTEC is involved in the PixApp photonic packaging pilot line project. This is an EU-funded partnership collaboration with a number of other partners, some of them in Ireland, some of them distributed across the rest of the EU. And we have some systems that are involved with that project. This is all part of the Tyndall Institute based in Cork in Ireland. Oh, we have an answer already, but from somebody I know, so I'm not going to answer that. So due to lockdown issues and that because people can't travel, then Peter O'Brien at the Tyndall Institute and leader of the PixApp program thought it might be an idea to try and use 3D real virtual reality videos to enhance or to provide remote access hands-on training for the machine systems. This is not something that is visible yet, but as part of that program, then there will be real 3D virtual reality videos made of use demonstrations on the ficonTEC systems that are at the Tyndall Institute and part of the PixApp program will be available online and can be viewed then through 3D goggles. Parallel to that, we are also at the same time exploring the use of animated 3D to provide a better visualization of our systems, not only for the website, for example, but also to people who have ordered custom systems, and this turns out to be most of them. And this will, of course, complement the real material that we have on file that we can show to potential customers or to people who are just interested. So that was the news for this week. If you are interested in finding out more about the PixApp, you will find something under projects and initiatives on our website. And of course, you can look up Tyndall directly online. Good. Okay, moving on to the next slide. Thank you, Kevin. So this is the schedule. We're changing up the schedule a little bit simply because it is proving to be a lot of work. Each individual webinar is not a lot of work, but by the time you've mixed it up with everybody else's commitments and other priorities, then it turns out we really should be doing these at the most once every 2 weeks. So what's going to happen is that the webinar scheduled for today, BondLine and CustomLine, takes place as normal. There will be no webinar next week. And the next webinar on high volume manufacturing will take place in calendar week 50, which is the 9th of December. That will be at the same time, of course, Wednesday, 3 o'clock. And then we have already set up the schedule for 2021. The schedule moving into 2021 will be every first and third Wednesday of the month. So this gives us a schedule of every 2+ weeks for the webinars. Some will, of course, get cancelled. Some will clash with real events. And we will just cancel the webinar on those dates. Kevin, next slide, please. Something I should have mentioned on that last slide, I guess, is that there are already 4 webinars online that you can view by view on demand. Just quickly coming back to my question for the day, somebody named Fabian, I don't know if he's internal or external, has named a housing format. That is the right answer. Andreas, do you know the answer to that question?
Yeah, I do. Should I say?
Good. No, not yet. Maybe later. Okay, so what is the goal of these webinars? What are we trying to do? Very quickly, some of you would have heard this before. We want to maintain the dialogue. We want to maintain the channel presenting news and information. We keep these short as much as we can. That makes them guilt-free because you can get back to work. And it's also an agile format. You will see news, developments, products, technologies, and depending on how many contributions we have externally, hopefully there will always be a question and answer session at the end of the actual meat of the webinar itself. Okay, Kevin, thank you. Next slide, please. So here we transition into the topic of today's webinar. We'll be providing an overview of the BondLine and CustomLine systems. Just for reference, we have done this already for the AssemblyLine and FiberLine. The webinar today will be taking a very similar format. In other words, we will provide you with a quick overview and then move quickly onto flagging interesting systems and interesting capability constellations that highlight the system diversity, giving you an impression of what our capabilities are and what sort of diverse markets and application spaces have already been addressed. Next slide, please, Kevin. First up is just to remind you as to where you can already find basic or intermediate information. Naturally, you will find PDFs on the BondLine, and to an extent, you will find complementary PDFs on FiberLine and AssemblyLine on our webpage. The reality is we don't have an up-to-date PDF of CustomLine yet. The reality is that the CustomLine capability is effectively any desired custom mix of BondLine, AssemblyLine, and FiberLine, and TestLine when it comes to that. And we're still working on the exact format we want to have for that PDF. You can, of course, find out more about other products, AssemblyLine and FiberLine, from a previous webinar that is available through View on Demand. And also other topics that come up again today are passive versus active alignment, and the webinar from last week, machine learning-based process control. These will all be valuable and play a role to an extent in the information or provide a background to the information that will be provided quickly today. Also, of course, on our Vimeo channel, and additionally on YouTube and on the website videos, you will be able to find assorted video snippets demonstrating process capability. Okay, thank you, Kevin. These are the 3 different platforms that form the basis of all of our products: entry-level standalone manufacturing systems and inline manufacturing systems. So the inline manufacturing next generation housings were introduced about 2 years ago and are now proven to be one of our most popular housing platforms, but not exactly the housing type. Andreas, I have a question, I guess, for you. So we probably deliver a fair number still of standalone manufacturing systems, I guess. Do you see a lot of those going through your group still?
Yes, so most of them are going through our group or through my group. More of them are standalone systems. Inline systems are also going through my group. But
I imagine the standalone systems are showing a fair mix of assembly, bond, CustomLine, and TestLine, if I'm correct.
Yes, that's correct.
Okay, next slide, please, Kevin. So quickly moving on, we have the 3 machine platforms. These form the basis for all systems that get delivered. I think it's best simply if you move on to the next slide. This shows in which housing formats the BondLine and the CustomLine product lines are available. Kevin, please. So we see that the BondLine systems are available in entry-level, standalone systems, and in inline systems. So all available housing formats can be had as a BondLine system, whereas for the CustomLine, these are available only in a 1500 or 2000 housing format. At the end of the day, this is exactly the same housing. There is just a different granite system forming the basis for the motion system. The 1500 is gantry, I believe, and the 2000 is a cantilever system. The same applies to the BL 2000. That will also be a cantilever system. Moving on to the next slide, please, Kevin. An important point to take away there in the last slide is that CustomLine is strictly a wide body legacy housing format, and the reason for that is simply because of what the design purpose of that particular system is. So what do these systems do? What do the BondLine and CustomLine systems do? What are their basic functions? The BondLine in particular is a thermal eutectic bond process system. So this could be with a thermal plate, and we have some images here on the left showing exactly that process. Top left, the first two images. It could also be a laser-assisted process. Sometimes those chips are active, they're driven. Sometimes those chips need to be flipped, but effectively that process can take place on anything that is an optical element, that is a chip, to an extent of fiber, in particular for the CustomLine, on arrays of any of those for hybrid assembly of optoelectronic dies, waveguides, PICs, etc. The CustomLine builds on top of that. The CustomLine is designed as our multifunctional platform where we are in a position, depending on the customer requirements, to add any of the features or any of the personas, if you like, that are available in other systems, including, for example, AssemblyLine, FiberLine, TestLine, inspection. So this means the CustomLine can include both passive and active processes, active as discussed for the AssemblyLine, FiberLine, which then in turn means epoxy-based, UV epoxy-based bonding processes, etc. Anything can be combined into this wide body housing platform, depending on the exact requirements. And what we find is that a lot of the CustomLine systems go primarily to R&D, to institutes, and for research purposes. To a degree, some of these systems can also include inspection and or test features. We will not be talking about those too much today. Okay, next slide, please, Kevin. What are the common features? So I hope to bring in Andreas for some of these points here. The first point, of course, is that these are, in general, these are fully automated precision die bonders. In the case of the CustomLine, of course, then we add other aspects in terms of fiber capability and active optical element capability. Eutectic bonding and selective laser soldering, I think we've discussed those already. Those are pretty straightforward. Both systems utilize a machine vision camera-based alignment. Andreas, can you maybe give us some details about exactly how that machine vision system works in terms of cameras and resolution, and what the idea behind that vision system is?
Yeah, thank you, Greg. So the idea behind the vision system is to, first of all, to detect very small parts, let's say with size of 100 to 200 microns or less, and actually align them both together to a submount or laser die to a submount. So the camera vision system has a huge advantage here because we can have a high resolution cameras on our systems with a resolution of pixel resolution in submicron. And actually the idea is to measure the submount, calculate the, for example, center of the submount or the solar area, pick the laser diode, measure the laser diode and place it above the submount in a submicron accuracy. So this is the idea of the camera-based alignment.
But they also form the central basis for the whole metrology system within the unit, right?
Yes.
So for calibration routines and...
Correct. So to manage all these steps, or to run all the steps, right? So first of all, you have to calibrate the camera system to each other. So we have mostly we have a top and a bottom camera, and in second step we have to calibrate the pickup tools or measuring the chips which have to be bonded. Out of those calibrations, we have reference positions and which are calculated and actually used for the placement positions.
And I think you've mentioned this already, but submicron positioning is also possible, even passively, I believe. But of course, it does require all the more time and resources to yield that accuracy in the motion system.
Right. So actually, it's always, let's say, it depends also on the camera setup. So you have a high resolution setup, and then yeah, it's possible to have a submicron placement. Also, we use, as you wrote down, we use an optical distance sensor for that. So if we have to align the overhang of the laser diode to the submount, which also helps.
Next common feature is adjustable bond force control.
So actually, we use adjustable bond force control for die bonding itself. So for single emitter bonding, or photodiode bonding. So we need to have bond force from, let's say, 5 grams to, if we're using laser bars, to 200 to 300 grams. We have different ways to measure.
And in what circumstances is optional post-bond measurement used? That is just effectively verification of chip performance or alignment, I guess, post-bond. Is that correct?
Okay, this is correct. So after bonding the chip to the submount, or after placing the one component to another component, actually we need to know, okay, what is the overhang, or what is the position of the die on the submount, and in reference to one reference position, or one position, or to another component.
Thank you. And depending on what level of modules and requirement by the customer, then these systems are capable of either handling single components or batches, depending on the exact feeding strategy that's applied, or even wafer level handling processing is something that we very much want to highlight for these systems. And across the board, not just for BondLine and CustomLine, across the board for all systems, we can employ OCR methodologies for component tracking and traceability. Let's move on to the next slide, please, Kevin. So what we have here is where we list some of the typical application spaces. On the left, we have the current CustomLine process snippets, or Schnipsel, as the Germans say, snippet video. So process steps, process shorties running in a video on the left-hand side of the screen. Typical tasks for BondLine and CustomLine are chip on submount activities, chip to chip, also flipping chips before they're bonded onto submounts, onto substrates. These can be employed for MEMS and MIMS. Sensor assemblies, for example, then for Internet of Things applications. I think we have a few biomedical applications for some of these systems as well. But miniature laser assemblies, PIX hybrid, integrated photonic chips, these are all the sorts of components that can be handled in general to an extent by the BondLine, and of course completely by the CustomLine system, because the CustomLine system can be decked out with a much larger flexibility and number of modules. And we will come to this in a moment. In terms of application spaces, then of course we're looking at communications. There are numerous different LiDAR applications, not just automotive, where the CustomLine systems can be employed in addition or instead of AssemblyLine systems, for example, for micro camera modules, high power laser diodes, micro LEDs in automotive headlamp applications, for example, and wafer level, whatever you like. As I mentioned, the CustomLine is really the system that is capable of addressing all of these different application spaces. The next slide, please, Kevin. Some of the feature highlights, we've touched on these already for the BondLine and CustomLine. We can achieve passive alignment down to 0.5 microns. As you would have heard, or if you still need to look at that webinar, if you would have heard in the passive and active alignment webinar, this is doable. It depends on the resources and the time you want to submit. You want to contribute to that particular process in aligning up the metrology system and all the components within, and also the optical elements themselves, if they provide sufficient accuracy and reproducibility in their features that are used for the passive alignment, then certainly that is a path that can be taken. As already mentioned, the CustomLine can include AssemblyLine and FiberLine modules and capabilities. It is effectively has been designed to be our multifunctional platform for exactly a wide range of diverse new product new product introduction, excuse me, and R&D and innovation activities. For some of these systems, they can of course be ordered in next generation inline housings, made for inline effectively, which means they are capable of applications in high volume manufacturing, as well as standalone applications for R&D and NPI. And again, as for all our systems, it is not just the hardware being able to place to 0.5 mu. It is the software that orchestrates the whole setup and makes the systems much more than just the sum of the hardware parts. Okay, so we want to move on to some of the application highlights over the next few slides. Kevin, move to the next slide, please. Thank you very much. So this is a video running in the background or on the right-hand side of this slide. This is if you like, a super size me application. Andreas, can you describe what we're seeing, what is going on here in the video?
Yeah, this was a BL machine. So what we have here is a huge chip, which has a size of 10 to 15 centimeters. And the idea here is to place the 6 chips to each other. So with a let's say with a pixel pitch of 7 microns. So the accuracy has to be 7 microns to each other, to another chip. So the difficulty of this process was that the size of the chip and the alignment of 7 microns was kind of tricky on that. So we have to measure at least 2 to 3 corners in the middle. And what you can see here, this is a sub-mount, which is a kind of a metal plate. And on the metal plate, there's a foil, a sticky foil. That means you have only one try to place the chip in the correct way to another.
So so when you think about it, right? Okay, first, I mean, that's a vacuum chuck we're looking at that's picking up the chips, of course. And if you want these things to be pitch or pixel perfect, then naturally that it has to be the case that you have to guarantee an accuracy below the pixel pitch in that case, right? So less than 7 microns, I assume.
That's right.
So the idea of this exercise was just to demonstrate the fact that naturally a lot of or most of the chips we see can be relatively small. Most of the dies we see can be relatively small, so down to 150 by 400 microns, for example. We have tools that pick up those sorts of components. But at the other end of the extreme, then we can move up to 10 to 15 centimeters along a side. And exactly in this video, you mentioned it yourself, Andreas, we see the degree of time and effort that's being put into measuring multiple points over that chip so that we can achieve that sub-pixel accuracy in lining those 6 dies up against one another. Thank you very much. Okay, then let's move on to the next slide, please, Kevin. This is a system I've brought up before. So this is a system that is installed at the Fraunhofer HHI Heinrich Institute in Berlin. This system is used for their polyphotonics and terrific research programs. These are funded, either German funded or EU funded projects. And their goal is to develop a hybrid optical toolbox that can be used for a diverse range of applications, including, for example, in the telecommunication space for optical interconnects. One of the points we want to highlight here, and I've mentioned this already, they have a CustomLine CL1500 that has, I guess it's approaching a dozen different process modules within a single housing. Am I anywhere close to the right number there, Andreas?
Yeah, I think it was about 8 applications we have to run on this CL1500. So actually, what you can see here, the image. So we have to have a kind of a chip bonding of a gain chip to a sub mount, then have place the fiber and into the V groove one application, then aligning the gain chip to another sub mount, and placing a filter. And another application was also placing a photodiode. and all those applications were run in one machine, or let's say in one CL500.
So in support of all of those, then you're going to need, I mean, some of them were, that looks like, it doesn't look like that's going to be with the fiber. That doesn't look like it's going to be a thermal bonding process. It looks like it's going to be epoxy, probably UV epoxy. So there needs to have been dispensing. I guess for the fiber, there needs to have been active alignment. For the chips, then you look, for the chips, then I guess you're looking at chip on substrate.
You're right.
Some of the processes were active, some of them were passive. And do you remember what the thin film was used for, or is that just, or that's part of the multiplexing, I guess, for the interconnect? I think what is it that we want to highlight here is that this is this is typical, I think, of what the CL CustomLine 1500 can do. It has been purposely designed as a system where you can mix and match any number of modules from the other assembly line systems to create that that system that addresses your specific requirements, but diverse requirements. If you're doing R&D for different projects, if you're doing new product introduction, and need to have flexibility in a single system to develop processes, to develop devices, and to be able to move that forward past the innovation phase, and then into a production environment or production status, of course. And this is exactly what the Fraunhofer HHI is doing in Berlin with the CL1500. If you go to, I think it is the Fraunhofer collaboration blog entry on our website, you will find a few links to an article that appeared in Laser Focus World on this application, on their activities, and also some links to some of the videos that they host that show exactly the sort of work that they're doing. And it's quite interesting. I recommend you go along and take a look. Thank you. Okay, so Kevin, next slide, please. So this was, I had to look this up myself. I did not know what stud bumping or stud bump bonding was. There is a link at the bottom of the page. This all falls under the topic of high force bonding. And I think, Andreas, you mentioned it the other day, that this was a process that required 60 kilograms of force to place a filter over a CCD array, I think. Is that right?
That's right, correct. This was one of our systems which we delivered 2 to 3 years ago to a customer, and the application was to place a filter on a CCD chip and bond this filter to the CCD chip with a stud bonding procedure. So yeah, the beauty of that was that we have to apply really a 60 kilogram force for this chip, and at the same time having a kind of a heat up to the oven, and yeah.
And of course, you have to be able to apply that force and still maintain yield over that small area.
Yeah, correct. Actually, the challenge was really to have this huge force of 60 kilograms, and I have kind of having kind of a hardware which can also handle this kind of force. So this is right. Kilograms. It's to the small area size.
So I had to look up the topic of stud bumping myself, or stud bump bonding. It is the process of bonding via an array of gold bumps that you place on top of your substrate, and then you add your various arrays, chips, whatever elements you need on top of those. Apparently, these can also be stacked on top of each other to achieve greater elevation. They are apparently in this process they achieve a height planarity of plus or minus 2.5 microns. And if you need a greater degree of accuracy in terms of planarity, then these things are then, the term is coined. So they are then mushed into the substrate and then look like little coins. And of course, they provide both the method for contacting, because gold is, of course, relatively soft. And of course, it's electrically conducting. So you're killing two birds with one stone there, I guess. And if you think about the filters that are applied to CCD arrays nowadays, and also the degree of accuracy, I think in smartphone applications, the pixel sizes are coming down to, or at least they were a few years ago, if I remember correctly, down to single micron or micron and a half pitch between the pixels. That gives you an idea for, at least for those applications, to what degree of accuracy then the other optical element arrays need to be placed on top. And of course, there are other applications here, just aside from biofilters. If you think in terms of hyperspectral imaging, then there are a very special constellation of filter types that have to be placed very accurately over the different pixels of the CCD chip to guarantee proper addressing for that particular wavelength to that pixel. Okay, thank you very much, Kevin. Next slide, please. So we could go on, we could present half a dozen different, or flag half a dozen different systems. We don't want to take up too much time this week. Some of them we can't mention in detail. We can mention the application space. So the idea here is we will run through some of these in a quick discussion sort of format. Brolis Semiconductors, for example, is a company based in Scandinavia. They have laser soldering systems that they are using to explore chip mounting applications. Seagate, do you remember what that system was? I believe it was some years ago, but do you remember what that system was for? What the peculiarities of that system were, Andreas?
The system was for hard drive reading head. So, this was kind of a chip bonding system for a hard drive.
Was it Arno, the product manager? I think he also mentioned the point that there was, so it wasn't bonding vertically. We actually then had the task of swiveling a component so that it faced upright, and then moving that onto the substrate or wherever it needs to be mounted. Fraunhofer ISIT in Itzehoe in almost the very north of Germany, I believe. So they are getting something that's not in our table of systems, which is at least officially designated a BL3000. That is a system with which they will be studying through silicon soldering using, I believe it's 1.4 micron infrared lasers. I will discuss that a little bit more in the next slide, so we won't linger here. Fraunhofer EOF, can you say something a little bit about that system, Andreas? Do you remember? I can take over. And I was told that what's special about that system was the wafer handling. It is a temperature-controlled wafer handling chuck, vacuum wafer handling chuck that can be heated. I forget to what temperature that was, but effectively this can handle up to 10-inch wafers, I think was the information, and various bonding and observation and placement tasks can then be performed on the heated wafer on top of that chuck. Another very interesting point, and I've touched on this before in a previous webinar, is looking at the CustomLine system that was delivered to C2MI. So C2MI is an R&D center based in Bromont, I believe that's in Quebec, in Canada. C2MI was founded together with IBM and Teledyne Dulcer. There we go. Teledyne Dulcer is a camera systems, or has been in the past, camera systems manufacturer or developer. And what C2MI does is they perform a lot of the fundamental research for various departments within those two organizations. C2MI has a CL1500, I believe, and that system is used for silicon photonics development. Most importantly, that system is also used by IBM's Silicon Photonics Development Group for their own process and device development purposes. And that is also, if you go to a blog entry on our ficonTEC Insider webpage, there is an entry that describes and links to exactly that application and gives some description and some insights as to what's going on there. Another application we want to highlight is for an automotive headlight application. There was a system developed recently for high-speed micro LED assembly, and I guess the particular aspect here was the parallel processing or the parallel movements and machine vision tasks that were carried out within that system, so that we could achieve a throughput of one device every 7 seconds in a micro LED headlight mounting application. Listed on the right are logos for some of those companies. These are just a handful of obviously where a large number of systems have been installed over the years. Thank you, Kevin. Moving on to the next slide. So I guess what I wanted to round up with is this the end of line for passive? For example, for BondLine applications. So we have soldering applications for the bonding task within that system, and the same is employed in the CustomLine systems. Additionally, we can add epoxy and UV cooled epoxy applications to the CustomLine. The point is that passive has definitely not reached the end of the line. We have at least two, certainly two applications that we can, or two activities that we can mention here, where we are trying to develop the ability, the capability of passive BondLine type applications further, so that we can save on other applications and steps that are then undertaken within those systems. For example, in a situation where you have combined passive and active alignment. This is the case on the left, and I mentioned this in the webinar last week, and we will see the results very quickly again on the next slide. The image on the left illustrates a process where you first undertake a passive alignment placement of a lens, of a fast axis collimation lens in front of a laser diode, and you're trying to achieve fair collimation of that laser diode in a subsequent active process. We'll come to the results then on the next slide very quickly. Moving to the right-hand side of this slide, then together with the Fraunhofer ISIT, what they are doing with that system, the BL3000 that they are receiving, is one of the activities they are looking at is through silicon soldering. We have an article in preparation for this that will appear presumably online with some publisher very soon. We hope to have that ready for you. Standard laser-assisted soldering processes uses a thermal conduction process through the substrate to then generate enough heat in the solder bump on top of the substrate to enable that solder process. This is a relatively slow process because of the thermal conduction that's required, and because of the risk of heat affected zone. So what HAZ stands for, heat affected zone. You run the risk of affecting previously soldered joints, so you cannot pack your devices or your solder joints, you cannot pack them so closely. And a new process that's being developed, we are using a different wavelength so avoiding the absorption within silicon entirely, and using a process and materials that enable the deposition of the heat directly underneath the solder bump. This enables greater density of solder joints, means you can pack your devices more closely together. It's a faster process because there's no thermal conduction, and all that needs to be done now is the development of doing this massively parallel, so that you can speed up the process either for a large number of dies or multiple points across a single die. Kevin, please, next slide. So very quickly, again, I showed this in the webinar from last week. What I want to demonstrate here is 4 passive processes we can use, for example, machine learning-based visibility provided for the data to yield a better understanding of the process and how it actually works. We see in the purple points here, we see effectively what we would expect from that passive lens placement process. Some of them are spot on, so to the bottom left of this graph, most of them we see are at a position away from the ideal focus, and we are in a position because of that data clustering to better define the initialization for the subsequent active alignment process, and thus bring those purple dots closer to the ideal position much faster than we would do ordinarily. We see a second data set on this plot where we are effectively in the position now to look at the process as a whole, look at the process initialization as a whole, and be in a position to perhaps define the process in a better way that avoids the second cluster entirely, and effectively moving everything into the purple data set. Okay, Kevin, next slide, please. So we're coming to the end of this presentation. what is in it for you? I think what we have done with these slides is we've demonstrated to a point. We work on a lot of collaborations, international projects and initiatives where we both draw but also give back to the ecosystem, to collaborative partners. And through that, we already have established a closely working R&D institutes, partners, international contract manufacturers as well, in working in different parts of the world. We have a customer base comprising the technology leaders across Europe, Asia, and North America. ficonTEC simply has that breadth and depth of process understanding to be able to better address potential customer needs. All you need to do is come and speak to us, and we can sit around a virtual table and discuss exactly how we can solve those requirements, combining our own expertise with the process requirements of the customer. Next slide, please, Kevin. So the last things effectively to mention here are to remind you where you can find further information. And again, I've mentioned this already to an extent at the start of the webinar. Look at our LinkedIn and Twitter channels, Vimeo, YouTube, and also our blog page. You can discover more about our products on our webpage through the PDFs. Looking at the videos, you can learn about capability. And on our blog, you will find several relevant entries that will give you more information about some of the things we've discussed today. Next slide, please, Kevin. Scheduling. I already mentioned the change to the plan at the start of the webinar. So moving forward, there will be no webinar next week. The next one will be in 2 weeks' time on high volume manufacturing. That is December the 9th. As always, that webinar will take place at 3 p.m. CET. Depending on your time zone, that time will be different. So I think, next slide, please, Kevin. I think we're at the end of that webinar today. Andreas, we have no correct answer in the chat. Would you like to give that answer to the audience? What is our most common, over the last couple of years, what is the most common housing format? So not housing type, what is the common most housing format that has been delivered out to customers?
Yeah, it is 800 format.
And it has been primarily assembly, is that correct?
Yes.
Good. So no winner this week, maybe next time. But thank you everybody for taking part. That ends our webinar for today. Andreas, thank you very much for your contribution, for taking part. That was very helpful. Unfortunately, we don't have any questions in the chat, and I have nothing lined up. So that concludes the webinar. Thank you very much, everybody, for listening. I hope that was useful. Goodbye, and thank you.
Thank you.